Vanakkam. Welcome to this course on Classics in Neuroscience. In this series of videos, we have been looking at the physiology of synaptic potentials and receptor potentials. In the last week, we looked at action potential and the physiology of action potential, or how nerve impulses are being conducted within a neuron. In this case, we are interested in understanding how information is transmitted between excitable cells, between a neuron and another neuron, or between a neuron and, for example, a muscle fiber or muscle cell. In this video, we will be looking at the life and work of Jack Eckles, a towering personality in the field of neurophysiology, a vocal person who spoke up a lot, who was famous for being vocal, and who also contributed a lot to improving our understanding of the central synapses. Remember, in the previous videos, we looked at the contribution of Bernard Katz and his work to improve the neuromuscular junction, which is a peripheral synapse. Is the mechanism the same in central synapses was the burning question, because Eccles maintained that in central synapses the idea of chemical transmission of information may not work. So, that had to be tested. So, that contribution of how the central synapses works came from the work of Jack Eckles. So, Jack Eckles trained over 200 students and over 500 articles, most of them in the field of neurophysiology. Tremendous contribution, a very vociferous person, someone who speaks a lot. He was a flamboyant personality, or as they call someone with this Australian pugnacity, someone who came from Australia with the pugnacity that was typical of Australians, or at least that is what the textbook says. And also a very prolific writer, 500 articles, must have been a prolific writer, because unlike the present day, even in the present days 500 articles is a lot. You must be a very prolific writer to produce 500 articles, but in the good old days the avenues for publication were not many. So, 500 articles over a career is a huge contribution. Perhaps it is useful to recount the life story of Jack Eckles and how his contribution to improve our understanding of the central synapses in the spinal cord. It might be useful to recount his life. Jack Eckles was born in 1903 in Australia, in Melbourne in Australia. He received an undergraduate degree and medical training and graduated with excellent grades or honours from University of Melbourne in around 1925. Because he was this excellent student, he also won the Rhodes Scholarship to visit England. In the good old days, that is the place to go to study, to pursue higher education. So, Eccles went to England, where he had the opportunity to collaborate with many interesting individuals, many brilliant scientists, starting with Sherrington, Liddell, Creed, Denny Brown, Fulton of the famous neurophysiology textbook fame. He had the opportunity to work with such stalwart, such doyens and such early investigators of neurophysiology, especially Charles Sherrington. So, Eccles contributed primarily in the revolution in central synaptic mechanisms. So, he contributed a lot on Charles Sherrington's work on reflex activity in the spinal cord to help publish the work led by Sherrington that was called as reflex activity in the spinal cord, that perhaps was submitted in a hurry or put together as one of the supporting documents to help Charles Sherrington win the Nobel Prize in that same year, 1932. So, in the meanwhile, I think Eccles won. In the meanwhile, I think he also received a BA and a DPhil from Oxford. I think in the late 1920s, early 1930s, and he took up a teaching position at Magdalen College and became a university demonstrator in 1934. Around 1934, he became a university demonstrator. Around the same time, Charles Sherrington accepted Jack Eckles as one of his students, the last of his students perhaps, to continue his investigation of the mechanisms in the spinal cord of both excitatory inhibitory mechanisms in the spinal cord. So, he interpreted this data as electrical transmission that happens in the spinal cord synapses. This essentially put him at odds with senior investigators like H. Dale. We have discussed this in our previous weeks and the previous videos as the soup versus sparks debate. Remember this? Please do check our previous video in this course, maybe a couple of weeks ago, on the soup versus sparks debate. H. Dale was much more senior and also a very vocal personality. Jack Eckles, a very junior person, also a very vocal personality. And remember our discussion of how Bernard Katz in his early years in the late 1930s when he was in England, he observed these two people having a serious fight of sorts in the conversation, but would later retire to the evening to have sherry and be friends with each other. So, it was more about the work, it was more about the science. The seriousness of discussion and the violence in the discussion was only confined to the science. One more example of that was how Eccles later named one of Dale's contribution as Dale's law. That name Dale's law was given by Eccles himself. Remember this from our previous discussion. So, Sherrington retired in 1935. A natural candidate to succeed Sherrington was Jack Eckles, but unfortunately because Jack Eckles was a vocal personality, he was his Australian brashness and pugnacity somehow did not go down well with the culture and the approach of Oxford. So, that position was given to somebody else. So, essentially Jack Eckles had to go back to Australia. This happened a lot of people trained in the UK and went back to the colonies, went back to the countries from there they came to continue their practice. So, in 1939 he was joined by Katz and Kuffler in Australia, where he was working in a small medical institute. It was not a big college or research college, it was not an institute where he would have rather preferred to work, but this is what he got. So, he was working there, but he found excellent collaborators in Bernard Katz and Stephen Kuffler. There is a famous photo of Eccles, Katz and Kuffler walking in Sydney, the 1942 photo. Students will share this on forum for you to see. It is also part of the textbook, you can check that out. famous photo of some great scientists. So, in 1939, Eccles reported how in the neuromuscular junction chemical transmission is happening. This was simultaneously reported by others. We mentioned this in the previous videos. Who are the others? Schaefer in Germany and Feng in China. We mentioned this in the previous set of videos. Remember, this was a great breakthrough to show that transmission or information communication between neuron and the muscle cell happens via chemical mediators. It was a great breakthrough, but it was essentially a disproving evidence of Eccles' own theory that suggested that communication happens via electrical transmission. So, this was the first set of evidence suggesting that neuro-neuronal communication or communication between a neuron and other excitable cells may be happening through chemical means. Is this true in central synapses is the question that we are still working on. So, in 1944, Eccles accepted a position in at the University of Otago in Dunedin in New Zealand. I think that was 1944, where he put together an excellent team of researchers. I think starting with Archibald McIntyre, and a few others, Wilfred Rahl for example. We have also discussed their work in previous videos. All along from 1930s until the 1944 when he joined the University of Otago, he was a little unhappy that he could not provide strong evidence to suggest for his suggestion that communication between neurons happen by electrical means. He was a little depressed over this until he met Karl Popper, who said you can only disprove hypotheses in science, you can only falsify hypotheses, but not prove hypothesis. It's a very interesting idea that has carried on to this day. It's a very important component of the scientific method that you can disprove hypothesis. So, he urged, or Karl Popper urged Jack Eckles to formulate hypotheses regarding excitation and inhibition in the central nervous system and try to disprove them. So, this was the new line of research, that a new line of investigation that Jack Eckles took up. It kind of suited his personality, I guess. This is my own interpretation, that he was able to take this challenging approach of setting up a hypothesis just to disprove it. Archibald McIntyre had trained or had worked in Rockefeller Institute, where he had the opportunity to interact with the German scientist who helped Hodgkin with his amplifier, voltage clamp and other things. What is the name of this German scientist? That is Jan Friedrich, I will write this, Jan Friedrich Toenis, I hope the spelling is right. I think it is Friedrich Toenis. Remember, he was a person who built the famous CROs. He was the electronics wizard who built the CROs, amplifiers and other toys that were considered extraordinary equipment or state of the art equipment for the late 1940s. So, Archibald McIntyre returned from America with this equipment to Dunedin, to the University of Otago in New Zealand to perform or continue his research. So, at that time Jack Eckles was using older equipment from older generations such as smoke drums, pendulums, glass negatives that were used by older generation of scientists like Keith Lucas, Edgar Adrian. Remember, we discussed this in the previous set of videos. that was the equipment that Jack Eckles was using. So, McIntyre's arrival really helped Jack Eckles to upgrade his equipment in a way. So, he started essentially collaborating or taking over the equipment of Archibald McIntyre. So, in the late 1940s and early 1950s, Eccles collaborated with scientists like John Coombs and Lawrence Brock. John Coombs was an excellent physicist who was very good with electronics. So, he was building those circuits that Jack Eckles would need for his experiments, and Lawrence Brock was very good with using the microforge to pull micropipettes. Remember, that was still the method in the good old days. So, he was very good with the micropipettes. So, this was the team that was put together by Jack Eckles that worked on this. So, at the time this team was interested in delivering electrical signals to the ventral roots of the spinal cord and measuring the outputs on the agonist muscles and the antagonist muscles. What they found was that if they stimulate a given muscle, say an agonist, what they found was that if they stimulate an alpha motor neuron, later these were identified, if they stimulate a given neuron that is connecting to a given muscle, say an agonist, it caused an excitatory postsynaptic potential in the muscle. That is something that you would expect, perhaps later shown as the effect of sodium and potassium conductances, as you would observe in the action potential that was later described, non-specific changes in sodium and potassium conductances that was later observed. But what he also found was IPSPs, that is, if you stimulate an antagonist, it led to inhibition, a hyperpolarizing current, not a depolarizing current, a hyperpolarizing current. If the antagonist motor neuron was activated, it led to hyperpolarizing current of the agonist or an inhibition. Remember, Eccles supported the electrical communication or electrical transmission hypothesis. He was a vocal proponent of the electrical transmission hypothesis, and this antagonist activation leading to hyperpolarizing current, or what is called as an inhibitory postsynaptic potential, could not happen in the same mechanism through which an excitatory postsynaptic potential happens. If an excitatory postsynaptic potential is happening through the flow of current from the neuron to the muscle directly, a similar mechanism cannot explain inhibition, because current is flowing, it should continue to flow. But that is not what is happening. What is happening is something else. Current is flowing in the neuron, but a hyperpolarization is seen in the output, in the postsynaptic cell, suggesting that there is inhibition, something else, and negation of this activation is what is happening, suggesting that this communication must be chemical, must be mediated by chemical means. Later, much later, the chemical mediator was identified to be GABA, and the mechanism through which this happened was through increased conductance of potassium and chloride channels. This was described much later. Of course, the neurotransmitter that was involved was GABA, but GABA's acceptance as a neurotransmitter happened much later, as we have seen in the previous videos. After his work in University of Otago in Dunedin, he then accepted a professor position in the newly established Australian National University in Canberra. As he was transitioning, he travelled to America and UK, where he learned about the latest developments in the field in terms of the work done by Hodgkin Huxley and Bernard Katz. And he had the opportunity to write his book. He summarized his work in his book called as the Neurophysiological Basis of Mind, the principles of neurophysiology. This book was a definitive work describing and assimilating all the latest works done by these great scientists of the early 1950s, Hodgkin, Huxley, Katz, and Eccles' own work and others. So, it became an important fundamental foundation that launched modern cellular neurophysiology and that helped to identify synaptic pathways. Eccles influenced further work in the identification of synaptic pathways and the synaptic organization of the central nervous system we will discuss in future classes. So, this line of work also inspired other scientists to pick up this line where to study intracellular recordings not just in the peripheral system but also in central systems, for example, in fish electric organ and cerebral cortical pyramidal neurons and several other systems. So, the first line of work that was proposed and championed by Jack Eckles inspired further investigation in the central systems of relatively primitive models, animal models, but still that was taken up. So, with this we come to the end of this video. In this video, we looked at the life and work of Jack Eckles and his contribution and his legacy in the development of neurophysiology as a field of its own and his seminal contributions towards understanding the synaptic mechanisms involved in the excitatory and inhibitory postsynaptic potentials involving central neurons. Thank you very much for your attention.